So hey guys, welcome back to the channel. This is your physics buddy, and today I'm welcoming you to another session on electricity and magnetism, which is going to be lecture number 5. In this session, we're going to talk about electric field due to dipole. We'll try to find out what is the expression for electric field due to dipole at axial point as on equatorial point. This is going to be another important session. Apart from this, we have already covered so many different units in the channel. Do check them out. Do try to understand what is being asked, how to solve FRQs, how to get MCQs done. Each and everything will be discussed here, ideally. Whenever we are starting something new, it takes time. So do give time. Do check this video out for 10 minutes to understand the importance of it. Let's do it.
So the question is, suppose there is a charged particle of 4 microcoulombs. You have to find the electric field at this point P, which is supposed to be 2 centimeter apart from this charged particle. So tell me the direction as well as the magnitude of the electric field which is supposed to be there because of that 4 microcoulomb charged particle.
Times 35 35960.
How did you got it? Tell me.
Just K times Q1 over R squared.
What is the value of K?
8.99 times 10 to the power of 9.
You can take it as 9 also.
Okay.
Alright, let's make few changes to the problem. Now I have put that whole system in a medium of dielectric constant 2. Now tell me how the value of electric field change.
It would be divided by 2, I think.
Yeah.
Electric field.
Yes, correct. One more question. Suppose there are two charged particles. One is 2 microcoulombs and another is 4 microcoulombs. They are separated by a distance of 1 meter. Now find a point on this line joining the two charges where the net electric field is supposed to be 0. Find a point on the line joining the two charged particles where E net is 0. Try it out. See, this is not how it's supposed to be solved. First of all, you have to assume that there is a point at which net electric field is 0.
Yeah.
Now, how you are supposed to solve it? First of all, try to look at the electric field direction because of these two charges. As we know, these are the positive charges. So electric field, because of this particular charge, will be directed at this point, whereas electric field due to this charge will be directed at this direction. Now, this is the point where the net electric field is supposed to be 0. So what we can do is, we can write E net is supposed to be 0. So the sum of these two electric field must be 0 as per the equation. So we can say that as the two electric fields are opposite in direction, so E1 should be represented by positive I cap, where E2 should be represented by negative I cap, as the two are in opposite directions. So E1 must be equals to E2. And when we substitute the values, so we get KQ1 by R1 square must be equals to KQ2 by R2 square. Now, what is R1 and R2? These are the distances. So we can assume that from the 2 coulomb charge, X is supposed to be the distance till the point P, and automatically from this point P to the 4 coulomb charge, it is going to be 1 minus X. As the question says that the distance between the two charges is 1 meter, so they are going to have this particular distances from this point where the net electric field is supposed to be 0. So we'll simply substitute the values. As K is there, both the sides, so we can cancel this out. So Q1 by R1 square. R1 is supposed to be X square, whereas Q2 by 1 minus X whole square. Now we simply have to substitute the value in order to find out the value of X. So Q1 is supposed to be 2 microcoulombs. So we'll write 2 times 10 to the power minus 6 coulombs over X square, which is equals to Q2, which is 4 into 10 to the power minus 6 coulombs, 1 minus X whole square. I will simply solve the equation. So this 2 will cancel out this 4. We get 2 here. Once we solve this equation, we'll have 1 minus X whole square must be equals to 2 into X square. Now, if we simply take square root both sides, so we'll get 1 minus X is equals to root 2 times X. When we solve this equation, we'll get 1 is equals to root 2X plus X. So when we take out X common from right hand side, we'll get x is nothing but 1 over root 2 minus root 2 plus 1. This is the distance of that point, distance of point P from 2 microcoulombs, where net electric field is supposed to be 0 between the charges. Similarly, if the question says what is the distance from the 4 coulomb charge, so we can say the distance from 4 coulombs charge, microcoulomb charge, will be 1 minus x, that is 1 minus 1 over root 2 plus x. When we solve this equation once again, so we'll get root 2 plus 1 minus 1 over root 2 plus 1. So it is going to be root 2 over root 2 plus 1. Now, the units is supposed to be meters, because the distance given here is in meters. So this is the way to solve this particular question. And again, this kind of questions will be there in the class test as well as in the end year exam test also. Just make sure that you revise everything to the point, and whatever we are doing in the class, you make notes as well as revise all the questions that we are supposed to cover. Similarly, whatever questions are there in the book or your class teacher asks you to solve, make sure you practice them out. It should be in a regular practice. You should not miss even a single day when you don't go through with these topics. If you miss any of these days, it won't be easy to remember all of these things, because these are not something which you can just go and do once a week and you can remember all of them. You have to practice them daily. Let's start our today's session. So today we have to talk about electric dipole and dipole moment, as well as we're going to talk about electric field due to dipole at various points. That is axial and equatorial. You might have covered these topics in the class also. Also, we are going to talk about electric dipole in external field, that how the dipole reacts when it is placed in external electric field. So we talk about different phenomena here, and remember one thing: one question will be there from this particular topic in your end year exam, and that too in FRQ section. So it's not going to be easy. You have to understand each and everything very deeply. Just make sure that you pay attention and give your best to the subject. First of all, let us define that what is dipole. A dipole is basically a configuration of two charges, or I can say a configuration of two equal and opposite charges. Equal and opposite charges means magnitude of these two charges is supposed to be same, but the nature is supposed to be opposite, that is positive and negative. And they should be separated by a finite distance. So that is something you need to keep in mind. Should be separated by a finite distance. Generally, the distance which we assume that exists between these two charges is supposed to be twice of A. Like for example, suppose we have two charges of opposite nature, like plus q and minus q. Now, this plus q and minus q are supposed to be equal in magnitude, but the nature is different. Like this is positive charge, this is negative charge. So the configuration of two equal and opposite charges, and when they are separated by a finite distance, such configuration is called dipole. So this is something we call dipole. Two opposite charges separated by a finite distance. Now, the distance can be taken as r, distance can be taken as a, but we generally used to take it as 2a, because this will help us to calculate the relation for electric field to a little easier extent, you can say. The formula becomes a little easy when we use 2a. Also, we explain here a quantity called dipole moment. So that dipole moment is represented by p vector, and this dipole moment is nothing but it is a product of either charge, whether it is positive or negative. They both are supposed to be same in magnitude. So the product of either charge and distance between the charges. So this is how we are supposed to calculate the dipole moment. Now again, this is a physical quantity which actually help us to express the relation between a charge, or you can say pair of charges that are supposed to be different in nature. Now you already know, if you're talking about dipole, so dipole simply means two poles. So these two charges generally act as two poles, and as we know that all when we're talking about two poles, they are supposed to be different in nature, like opposites. Also, if we talk about the unit of dipole moment, it is going to be coulomb meter. Charge is supposed to be coulomb, and distance between the charges is supposed to be measured in meters. So the unit is going to be coulomb meters. So always remember, dipole is something which is supposed to be known as a configuration which consists of two charges of equal magnitude but opposite in nature, that is opposite in sign, or you can say positive and negative charges. So this is something we form, this is something how a dipole is formed. So there's one question. The question says polar molecules are the molecules. So whenever we are talking about polar molecules, let me just give you a few examples of polar molecules. Like for example, H2O we are talking about. So if we just look at the molecular structure of the H2O, it is supposed to be like that. Although it should have an angle between 107.5 degree between them. So here the oxygen is supposed to be negative in nature, carrying negative 2 charge, whereas the hydrogen is supposed to be positive in nature. So ultimately what we are looking here, we are looking here that there must be two dipoles that are directed from O in the opposite direction because of the nature of the charge. So a polar molecule is something which always forms a dipole. So if you just understand this particular thing, we can answer this question now. So polar molecules are the molecules having zero dipole moment, acquires a dipole moment only in the presence of electric field, acquires a dipole moment only when magnetic field is absent, have a permanent dipole moment. So this is something we can answer here. So a polar molecule is always something which is having a permanent electric dipole moment. This is something you have to keep in your mind about polar molecules. Although there are so many examples of polar molecules, another example we can talk about HCl. So here hydrogen is supposed to be positive and chlorine is supposed to be negative. Again, they are forming a dipole. So they always have a permanent electric dipole moment. That is what we need to understand about electric dipole. Now, how can we calculate dipole moment? I already told you it is a vector quantity. It is represented by p vector, and it is nothing but product of charge and the distance between the charges. So we can simply represent it this way. Now, as I told you that it is a vector quantity, so vector quantities always have direction. So when we are going to define the direction of dipole, electric dipole, so its direction is always directed from negative to positive charge. So whenever the question says that how the electric dipole is formed, so we'll say the direction of electric dipole is from negative charge to positive charge. Like for example, suppose I have few configurations. This is positive, this is negative charge. So the direction of this particular dipole is going to be directed this way. This is how we are supposed to represent its direction. Or we can say here the dipole is supposed to be negative of I cap. Similarly, suppose if we having two electric dipoles placed at 30-degree angle. Like for example, this is plus 2q and this is minus q, this is minus q. So in this particular configuration, electric dipole is supposed to be directed this way in both the cases. So if you just look at the dipole, they must be making an angle 30 degree between them. Also, try to understand that how the direction is directed, because direction is something which is very important to understand the net electric field when we are going to talk about it later on in this session. Again, a very important topic, and one FRQ will be there from this particular section. Remember this. Units. If we talk about its unit, so its SI unit is coulomb meters, that is cm, and dimensions is LTA. Also, it has some practical units. So the unit which we sometimes use is called dB, and dB is something which is defined as when two equal and opposite point charges having charge 10 to the power minus 9 Franklin separation of 1 angstrom. 1 angstrom is equals to 10 to the power minus 10 meters. 1 dB is also equals to 3.33 times 10 to the power minus 30 coulombs meter. This is again little important. Always remember how what 1 Franklin is. So 1 Franklin is equals to 3.335 times 10 to the power minus 10 coulombs. Now this is the one unit which is given by the scientist, or the name of the scientist who discovered what electric dipole is. So Franklin was a person who actually expressed, or you can say defined, electric dipole. So these are the units that we actually going to use to find electric dipole moment. So the question is, find dipole moment in the given case. Now it is pretty simple. First of all, let us try to find out the direction of dipole moment. So as I already told you, dipole moment is always directed from negative to positive charge. So in this case, the dipole moment must have direction negative to positive this way, like that. So if we define its direction, it is going to be positive I cap, like that. Always remember, if we are defining direction in x-axis, it is represented by I cap. If we are representing direction in y-axis, it is represented in j cap. And if we are representing direction in z-axis, it is represented by k cap. So this is very important. Sometimes we are representing different directions using this I, j, k caps. So here we understood that the direction of this particular case is going to be positive I cap. Now the dipole moment. Dipole moment is what? It is a product of charge and product of either charge and distance between the charges. So we can take here charge as q, and the distance between the charges given in this case is L. So the dipole moment in this case is represented by QL I cap, where QL is representing the magnitude of the dipole moment, where I cap is representing its direction. This is very important. Most of the time, what you'll observe that the class teacher don't go that much deep into the topic. But when the question is asked in the exam, that question will definitely ask you these small things. So we have to remember each and everything. Another question. Now you have to find the dipole moment in this case. Now I guess you can answer it it's very easy, quite similar to the last one. Try answering this question. What is the dipole moment in this case? In this case, you have to tell the magnitude as well as the direction. Think and tell me. What is dipole moment? First of all, tell me that. I can't hear you.
Yeah, okay. Polarity of a
How?
molecule, like the measurement of the polarity of a molecule.
Yeah, that's fine. But what is the formula of the electric dipole moment? How are you supposed to find it?
P equals Q times D.
And what about in this case?
Uh, Q times 2A.
Exactly. And what about direction?
Direction is towards left side.
Towards right side. Direction is from negative charge to positive charge. So if it is towards right side, we'll represent it by I cap. Or you can also write that thing that it is directed towards right. So it's your choice to either use I cap or to write it in words, like wherever it is, towards right side or towards left side. So keep this point in mind. Now, another question, and this is the similar one. There is nothing different here. So again, it is going to be Q times 2A, and again, it is directed towards right side. So we'll simply say it is going to be positive I cap, or we'll say it is directed towards right. It's a similar one. But here the twist is the two dipoles are placed parallel to each other. So for the first configuration, it is going to be this. For the second configuration, again, it is going to be this. So the net dipole moment in this case is going to be P1 plus P2. And as both of them are in the same direction, so we'll simply add them. So Q times 2A plus Q times 2A. So it is going to be 2 times Q2A, which is 4 times QA. So this is the net dipole moment. And we'll again define its direction, that it is directed towards right. So it's not like only one dipole is being there in the system. There can be more than one dipole given in a system. And here you have to find out the net dipole moment this way. Always remember these points. We are going to use this when we're talking about electric field due to dipole at various points. Now, a different case, and here we are supposed to find out again the dipole moment of the system. So in order to find out the dipole moment of the system, you can see here that there are two charges, or you can say there are three charges. The one is supposed to be negative 2q, another is supposed to be positive q and positive q. So here, if you actually express the dipole direction, so for these two charges, let me just do one thing. I just assume that there are two charges, minus q and minus q, placed here, and here there is plus q, and again there is plus q. So for these two charges, there must be a dipole moment. For these two charges also, there must be a dipole moment, as they are separated by some angle theta. So we can say that for first two charges, dipole is directed this way, negative to positive. Direction is important. And again, for this particular charge, it is going to be directed from negative to positive, like that. So here we understood that there are two dipoles separated by some angle theta. This is P and this is P. As both the dipoles are of same magnitude, because the charge and the distance is same in both the case. So here the dipole is going to be Q times 2A. Now, if we have to find the net dipole moment, we have to use the net, or you can say the resultant formula. What was the resultant formula? If we are finding resultant of any given vector, any given two vectors, it is going to be a square plus b square plus 2ab cos theta whole square root. So in this case, we have to find the net dipole moment. It is going to be a square, which is p, b square, which is again p, twice of a b cos theta. As the angle is not mentioned, so we'll keep it this way only. So here we'll get p net is going to be 2p square plus 2p square cos theta. What we can do here, we can take 2p square common. So 2p square, if we take out as common, we are left with 1 plus cos theta, and it is going to be root. So again, this p square can be taken out from the square root. So we'll be having p times root of twice of 1 plus cos theta. So this is going to be the net dipole moment in this particular case. Always remember, physics is not easy. You have to be more attentive, as well as you have to understand all the situations quite well. This is the way to do this particular problem. And remember, one of the questions will definitely be there in a final exam from this particular section. This is somewhat like very favorite of the dear teachers. They always used to ask questions from this particular topic. So we need to take care of this. Understood?
Okay.
Another case. So here again, we have to find out the dipole moment. So in order to find out the dipole moment, we have to first of all see that how the directions of dipole moment will be directed. So just try to understand it this way. So this is negative 3q charge. This is positive q. This is positive q. This is positive q. What we can do here? We can consider this negative 3q charge in three ways: negative q, and negative q. So if we just do that and try to get the directions of the dipole moment because of this particular configuration. So we'll see, this is plus q, this is minus q. Now again, this is plus q, this is minus q. Again, this is minus q, this is plus q. So whenever you have different charges, you have to first of all form the dipole, like how the dipole is being created there. So here we can see now, this is one dipole, this is another dipole, and this is another dipole. And also the direction of dipole is always directed from negative to positive. So one is going to be there, one is going to be there, and one is going to be there. And all of them should be of same magnitude as the direction, as the nature and distance between the charges is supposed to be same. So here I can see that the distance between this charge and this charge is going to be 2a. So you can mark it as P1, P2, P3. So P2 is going to be Q times 2a. But what about these two charges? What about other two dipoles? Are they having same distance? No, it is not going to be 2a. So the distance between these two charges is going to be different. And how we can find it out? By simply using the given information. As the distance between this and this is a, so it is ultimately going to be root 2 times a. I have simply used the Pythagoras theorem, and Pythagoras theorem will give me root 2a distance. So P1 must be equals to P3, it must be equals to Q times root 2a. So if we try to understand this particular question, this is not saying this is not easy. You have to understand each and everything quite well. Now, the concern of finding this angle, this is also important here. How you are supposed to find out this angle? That is another question, because without finding this particular angle, we cannot actually find net dipole moment of the system. So let us try to do that. So as you look at the given situation, we can find out this particular angle using Pythagoras. Just look at the problems carefully. This is A, this is A. This is going to be 90 degree, that's for sure. Now if I just turn this particular diagram clockwise, so this is A, this is A. I have to find out this angle. Can I use tan to find out this angle? What is tan? What is tan theta? Tan theta is this adjacent over this base. So it is going to be 1. So theta is going to be 45 degree here, because we know that a tan has one value when the angle is 45 degree. So here we find out the angle. It is going to be 45 degree. But what about the whole angle between these two? It is going to be 90 degree. P1 and P3, which are having same dipole moment, having angle between them is 90 degree. So we are finding the resultant of these two dipoles. It is going to be a little tricky. Let us try to understand it properly. So here what we have seen, that there is one dipole and there are two different dipoles as well, separated by 90 degrees. This is P1, this is P3, and this is P2. P1 and P3 are equal. And how much they are? Q times root 2a. So if you look at the angle between them, as it is 90 degrees, so how can we find the resultant of given two vectors? Again, by using the same relation of resultant. So resultant is given by a square plus b square plus 2ab cos theta. So let me just consider it as p only to solve this equation in a simple way. So p square plus twice of p square cos 90. What is the value of cos 90?
Zero.
Yeah. So resultant of these two dipoles, that is P1 and P3, is going to be root 2 times P. Now what is the value of P? P has a value Q times root 2a. So resultant of the first and third dipole is going to be 2QA. Now we got resultant of first and third dipole. So the resultant of first and third dipole is root 2QA. And now what you can see here, that the P1, or you can say the P2, was already aligned in this direction. And the resultant of these two dipoles is also going to align in the same direction. And also if you see, it is also having the same magnitude, just like as the initial one, P2. So the net dipole of the whole system is going to be the sum of these two dipoles, which is supposed to be 2QA plus 2QA, which is 4QA. So this will give me the net dipole moment of the whole system. Now if we talk about the direction, it is directed vertically upward. We can say it is represented by J cap. Again, I would say all these things which we are learning here, these are not easy. You need to be mathematically very strong, as well as a focus need to be very strong. You need to be really focused while understanding these three things. And remember to revise each and everything every day. Whatever we are learning, what you can do is just try to solve at least 3-4 problems every day. Whatever topic we are going through, just make sure that you try at least some of the problems from that topic. What this will do to you, this will actually help to remember the concept. Not now, not for the exams, but at least for some times that it is needed. And everything we're going to learn here in physics, one unit after another unit, all the previous things which you have learned, they are going to be used somewhere sometime. So you can only apply all these things when you actually remember them. And how can you remember them? By simply revising them daily. So just make sure these things are very important and you should follow these things as I say. Whatever questions you're doing in the class, you can at least try these questions once again at your home once you are not doing the class or all the other 4 days. You can at least try these questions as well as you can go the theory part, read book, solve the questions there in the book, do examples as well as do some problem from the exercise also. If you'll do it, it will help you. Again, if you're not, you'll forget these things. These are very important. So this is the question again from dipole moment only, and this is going to be your homework. Once you get the PDF, make sure that you solve the question and revise what we have done already also. So this K
Okay.
cap is actually representing the direction. So just think wisely once you're trying this question. It will be easy if you keep all the things we have just looked in mind.
Okay.
This is also going to be your homework. The same question which we have studied, like this one. It is similar to this question, but now the angle becomes 90 degree. So if angle becomes 90 degree, you'll put the value of cos theta as cos 90. So ultimately the answer is going to be root 2 t square. We'll solve it, we'll have the answer. You can do it, make sure you try to solve that. All right, so this is the most important part I was talking about. Questions that can be asked in FRQs, which are very important. The examiner can simply ask you what is the electric field due to a dipole at axial point. So actually heading towards the derivation part, first of all, we need to understand what is axial point. So axial point is any point lying on the axis of dipole at a certain distance. Like for example, suppose this is a dipole. Again, dipole is a configuration which consists of two charges, positive and negative of equal magnitude, separated by a certain distance. So what we have assumed here that this is a dipole, and the line joining the dipole, if we extend that line in both the directions towards right side as well as towards left side. So all the points which are lying on this line, these points are supposed to be called axial points. So sometimes, like how the question is being asked in this particular question or this particular from this particular topic, the examiner will ask you to derive the relation for the electric field due to dipole at axial point, and then later on it will give you a configuration about which for which you have to find out the electric field mathematically using the relation which you have derived. So this is how you're supposed to answer this question. Let us try to understand it. So what we are going to do here is we are going to assume a dipole and and on the line of the dipole a point which is supposed to be called point P. Now what you can see here is for this dipole from the center, we just assume that the point P lies at a distance r. Now this is important. Always remember what we are doing here. And the distance between the dipole is going to be 2a. That is something we already know. Now, why we take 2a? I already told you to make the derivation part easy. We can take L, we can take R, we can take A, but if we are taking 2a, 2L, 2R, it will help us to solve the question or solve the derivation quite easily. So, from the midpoint of the dipole, we have taken R distance. Why? You'll understand it soon. So, if this question is being asked in FRQ, you have to explain the configuration also, that whatever you have assumed, what are the distances given here, and all the other aspects, you have to explain these things. So, you simply write, consider an electric dipole separated by 2a distance, separated by 2a distance, such that a point lying on its axial line, and we will find electric field at that point. So we'll try to find out the electric field at this particular point, which is called axial point. Now, in order to find out the electric field at this point, first of all, you need to understand the direction of electric field because of these two, this dipole, or you can say these two individual charges. In order to do that, you need to understand and you need to remember the direction of electric field, which we studied in the last class. If suppose it is a positive charge, so electric field is always directed away from positive charge. So if it is a positive charge, electric field is going to be away from it. So if this is a positive charge, electric field is going to be away from. So I can say it is going to be E plus Q. Similarly, if it is going to be negative charge, electric field is going into this charge. So if this is a negative charge, the electric field is directed this way here towards the charge. So this is the basic thing that we need to understand first of all, that is what is the direction of electric field due to positive as well as due to negative charge. So here we have to find out the net electric field. So how can we do so? So we know E net at point P is going to be sum of these two electric fields. Whenever we are finding net electric field, or you can say whenever we are finding the net of any given vector, we'll simply add them. But not only the magnitude, we also have to add their direction. So how we're supposed to write the direction, that is also important. So I can write E1, it is directed in x-axis, that is positive x-axis. So I'll represent it as positive I cap. Whereas E2 is directed in negative x-axis. So I'll write negative I cap like that. So this positive and negative I caps are actually representing their directions. Again, remember, whenever we are solving vectors, we have to add vectors, their magnitude as well as their directions. If we don't do that, it is going to be, it is not going to give us the answer or the result we want. So that is something you need to remember. Now, let us try to write the value of E1 and E2. Or you can say E plus Q and E minus Q. So E plus Q, if you understand, what is the formula for electric field? It is simply KQ by R square. So K plus Q, again, it is going to be Q. Now, R square is the distance of charge from that point. So if you look at the positive charge here and this point P, what is the distance between the point P and the positive charge? Try to answer it in terms of R and A. What is the distance between this point P and positive Q charge? Try to answer it in R and A, in terms of R and A. Just look at the diagram carefully and try to answer it. What is this distance is going to be?
R plus A.
R is the distance from the center of the dipole to this point P.
R minus A.
Exactly, R minus A. So it is going to be R minus A whole square. So if you have to write it this way only. Similarly, if you have to write P due to negative charge, it is going to be again KQ over. Now it is going to be R plus A whole square. Because from this negative charge to this P point, the distance is going to be R plus A, which is this. So we'll simply add these to R and A. Now what we'll do, we'll simply substitute these two values in this particular E net equation. So we're going to have KQ over R minus A square plus KQ over R plus A whole square. Now, remember the direction. We have to keep the direction intact. So if we just try to ignore the direction, so what we are going to do is we have to substitute this negative sign of the direction into this particular part. Or you can also understand it this way, that whenever there are two vectors directed opposite to each other, whenever we are going to add these two vectors, we are actually subtracting these two vectors, because these two vectors are going to, we can say, counter their effects. They try to nullify their effects. So the E net at the point P is going to be K, Q, I can take them out as common, R minus A square minus R plus A whole square. This is how we are supposed to write it. So K, Q. Now, if we solve this equation, we'll get R plus A whole square minus R minus A whole square. And in the denominator, we're going to get R square minus A square whole square, like that. Now, this is the calculation part. And this is something which you have already learned in previous classes or previous grades. You have to remember this particular part. So KQ R minus A whole square minus R minus A whole square. Now let us just simply solve this equation. So we can have the electric field at axial point. So E net at point P or axial point is going to be R minus R plus A square, was it initially? So if we solve it, it is going to be R square plus A square plus 2RA minus another bracket was R minus A whole square. It is going to be R square plus A square minus 2RA. And the denominator is supposed to be R square minus A square whole square, like that. Now we simply have to solve the equation. So R square plus A square plus 2RA. If we open this bracket, the signs of all the quantities there will change. When they will change, we'll ultimately have R square will cancel out R square, A square will cancel out A square. We're going to have 4RA over R square minus A square whole square, like that. So this is the relation we actually use for finding electric field to dipole at axial point. But there are few cases. So, or you can mark it as a special case, and this special case is something which we actually use to find out the relation or the given scenario. This special case is if R is much more than A. Like for example, in this diagram, if this R becomes much more than this given distance A. So what will happen? If it is more than that, we can simply eliminate this A from the denominator. And if we eliminate this A from the denominator, okay, one more thing, KQ was outside. We have taken KQ common, so they remains outside. We cannot forget it. You can see here KQ was outside. So if R is much more than bigger than A, so what we can do is we can simply neglect this R from we can simply neglect this A from the denominator. So E net at P point is going to be KQ4RA over R square whole square. So if we solve it, we get E net is equals to KQ4RA over R to the power 4. If we solve it further, we got KQ4A over R cube. Now, what we already studied, we studied that dipole is nothing but Q times 2A. So if dipole is Q times 2A, and if we just try to put the value, or we just try to replace Q2A by P, so we can write KQP, and this 2 will remain, not Q will not come here. It is going to be twice of KP over RQ, like that. So this is the net electric field which we actually saw at axial point due to dipole. So I guess you must have seen this particular formula in the class, and you might have solved some questions also based on this formula. Have you seen this formula?
Yeah.
Have you done the derivation part, like how this formula actually came?
No, we haven't done that yet.
Yeah, but it will be there. If not in the
I
class
think
test,
it's the subject is algebra based. It won't ask calculus questions though.
it doesn't have any calculus part. It is algebra only. We're
Okay.
doing plus minus only. Yeah. Calculus part involves integration and differentiation, and we haven't done that. So this is a
Okay.
part of algebra only. We have simply
Okay.
just substitute and solve the different things, plus minus only. So it will be there. Remember that.
Okay.
So this kind of thing will be there in FRQs, and you need to understand that how you're supposed to solve this particular problem also. Now there is one more thing, or we can say another aspect of finding electric field to dipole, but at equatorial point. Now we need to understand what is equatorial point first of all. So equatorial point is a point which lies above dipole, above or below dipole at any point passing through the midpoint of the dipole. Now what does it mean? It means suppose there is a dipole like that, and if we just try to draw the midpoint, if we just try to pass a line through the midpoint. So this line is something we call equatorial line, which is passing through the midpoint of the dipole. And any point lying on this line, this, or even this, these points are called equatorial point. So you simply need to understand what equatorial points are. First of all, this is the thing that you need to understand at the first sight. Now, again, there can be a question where the examiner might ask you, find out the dipole field at equatorial point. So how can we do that? Let us try to understand it. So there are two charges, negative Q and positive Q, that will form a dipole. And what we have assumed that there is an equatorial point which is at r distance away from the dipole in the perpendicular direction passing through the midpoint. So this is that point. So this point I have assumed as the equatorial point. Now, to find electric field at this point, first of all, we need to understand that how electric field is actually directed. So as I already told you in the last derivation, because of this positive charge, electric field must be directed away from positive charge. So this is E plus Q. This line, this vector is representing E plus Q. Whereas because of the negative charge, electric field is actually directed towards it. So it is going to represent E minus Q. Now, how we are supposed to find out the net resultant of these two electric fields? In order to find out the resultant of these two electric fields, what we are supposed to do, we are actually solve these two fields in the component. So what we know is along the theta, the electric field must have a component which is called E cos theta. So it is going to be E plus Q cos theta directed towards negative I cap. Similarly, this E negative and another component must be lying there, which is supposed to be E plus Q sine theta. Similarly, this E minus Q again going to have two components, which is going to be E plus E minus Q cos theta, and another component which is going to be E minus Q sine theta. Now, what we actually see here is that these two components actually nullify each other because they are directed in the opposite direction. They will cancel out each other, and these two components will actually result in the net electric field. So what we can do here is we can simply add these two components and we'll get the value of net electric field. Let us see how can we do this. So E net is going to be twice of E cos theta. That's it. And they are directed opposite to this dipole field. Like for example, if you just look at the direction of dipole movement in this particular dipole, it is lying from negative Q to positive Q. So it must be there in this way. But the net electric field is directed this way, opposite to the direction of net electric field. So what we can do here is we can simply represent that it is negative P cap. This negative P cap is actually representing that the net electric field is opposite to the direction of dipole movement. So let us try to substitute the value of electric field. So electric field is what? KQ by R square. Now, what is R square? That is the question. So R is going to be this distance. This distance is going to be R square. How can we find this? We can again find it using Pythagoras. This perpendicular is R and this base is A. So this perpendicular is R and base is A. So the net, this distance is going to be A square plus R square whole under root, like that. It is going to be A square plus R square whole under root. But what is the formula of electric field? KQ by R square. So we have to do the square of that whole thing. Also, we have to find out the value of cos theta. So we have to find out the value of cos theta. We can use this triangle only. We already know cos is nothing but base upon hypotenuse. So base is A and hypotenuse is the same, A square plus R square, like that. We'll mention the direction, which is supposed to be negative P cap. So the net electric field in this case is going to be 2KQA over A square plus R square. So if you solve this, the square root will cancel out the square. So this is the whole power will be 1 and this is the whole power will be half. So it is going to be 3 by 2. So power is going to be 3 by 2. We just try to substitute the value of P here, that is 2QA. So it is going to be KQ over A square plus R square whole to the power 3 by 2. Negative P cap. Again, direction is important to represent. So this is the formula that we actually use to find out net electric field at equatorial point. But there are some few changes that we can make based upon this special case. So special case suggests us that if this R is more than A, so from here we can neglect this A. So if we neglect this A, the net electric field is going to be Kp over R cube negative P cap. This Kp, now this E net is going to be net electric field at equatorial point, and you already have seen this in the classes. So what is important here is that you need to understand that how this relation actually came, because the method of derivation is not something that is important to remember from the point of view of exams, but it is also important in order to solve the numericals. Because in numericals, sometimes we are not able to actually apply the relation, but if we know the process that how we actually derive that relation, we can actually solve that problem. So that is the importance of understanding that how that relation came. And you must have seen this relation also, and that is something we need to understand here. Does all these things make sense?